Welcome back. In this video, we are going to solve problem 10-75 that is taken from chapter number 10, Strain Transformation, and book name is Mechanics of Material by R.C. Hibbeler, 9th edition. And the topic that we are covering is theory of failure. Now, statement is the component of plane stress at a critical point on A36 steel shell are shown. Determine if failure yielding has occurred on the basis of maximum shear stress theory. So you can see this is the state of stress, plane state of stress, because there is no stress in z direction, so we take this as plane stress problem. So stress on this face is 70 megapascal. On top face this is normal loading, which is 60 megapascal, and this is shear stress, which is 40 megapascal. So let's start with the solution. So what we are going to do is that we will take this x, the direction is positive axis, and this direction is taken as negative axis. And you can see this surface or this edge is perpendicular to this x-axis, or this x-axis is perpendicular to this. So the stress that is acting over it will be represented as sigma xx. So I will write this as sigma x. Similarly, in the y direction, we know that this is sigma y, and you can see that this is the plane which is perpendicular to the y-axis, and here the shear stress occur in the x direction, so we will call it tau of xy. So I can write it that this is tau of xy. So again here I will write sigma xx is 70 megapascal, where sigma y is minus 60 megapascal, because you can see in the figure that this is compressive, and you have tau of xy, which is 40 megapascal. Why this is positive? So you can see this is tau of xy, this one. Why? Because you can see this is the plane that is perpendicular to the x-axis, and here this shear stress act in the direction of y, positive y. So we will call this tau of xy is 40 megapascal. Okay, now we have all these values, so we know that principal, we will first find principal stresses. So principal stresses sigma 1 and sigma 2 can be obtained by using this equation, that is equal to sigma average plus minus r. Now what is sigma average? So sigma average is equal to sigma xx plus sigma yy divided by 2. So you have value, this is 70 plus minus 60 divided by 2. So I have calculator, so 70 minus 60 divided by 2 is 5. So sigma average is 5 megapascal. And what is r? So I can write it that sigma r is equal to sigma xx minus sigma yy divided by 2 whole square plus tau of xy whole square, and all these values are in square root. Okay, so just put the value. We have this r is sigma x is 70 minus 60 divided by 2 whole square plus tau of xy is 40 whole square under the root. So let's calculate that. I will take 70 plus 60 divided by 2 is 65. So answer square plus 40 square under the root of this answer will give you 76.321 megapascal. Now we know that we have sigma 1 is equal to sigma average plus r, while sigma 2 is equal to sigma average minus r. So sigma average is 5 plus 76.321, while sigma 2 is equal to 5 minus 76.321. We will calculate them. 5 plus answer is sigma 1 is equal to 81.32 megapascal, while this sigma 2 is equal to 5 minus 76.321, and that is equal to minus 71.32 megapascal. Okay, now you have both these 70 sigma 1 and sigma 2. So what you are going to do is that if you draw them on a Mohr circle, so let this is on Mohr circle, you have this as sigma and this is shear stress. Okay, so on this x-axis there is no shear stress, and this is known as principal plane, and this principal stresses always acts on principal plane. So sigma 1 is positive and sigma 2 is negative. So I will write both sigma 1 and sigma 2 have opposite signs. So if I draw it on this principal axis, so let's say for example this is sigma 1, which is equal to 81.32 megapascal, and this is sigma 2, which is equal to minus 71.32 megapascal. So if I draw a Mohr circle in between these 2 points, so it will be like that. It will be a pure circle, but here I do not have any tools to make this, so that's why. So this is the pure circle, and at this point you have sigma 3 is equal to 0. So Mohr circle between sigma 1 and sigma 3 will be like this, while sigma 2 and sigma 3 will be like this. So you can see here that the maximum shear stress will be this one, which will be, we can write it as maximum shear stress. So we'll find this maximum shear stress. So maximum shear stress, here you can see this is equal, this is the radius of circle, this is also radius of circle. So you can see this distance divided by 2 will give you the radius. Clear? And how we'll find this? This will be equal to sigma 1, absolute value of sigma 1 minus sigma 2 divided by 2. So put the values, sigma 1 is 81.32 minus 71.32 divided by 2. So I will get the maximum shear stress will be equal to 81.32 plus 71.32 is 152.64 divided by 2, and that is equal to, if I divide it by 2, so it will be equal to 76.32 megapascal. Now we have this value of maximum shear stress. So according to maximum shear stress theory, which is also known as Tresca criteria, so if sigma 1 and sigma 2 have both opposite signs, so maximum shear stress, which is equal to this term x, which was equal to sigma 1 minus sigma 2 divided by 2, it should be less or equal to, sigma yield divided by 2. And why? Because sigma yield divided by 2 is equal to maximum shear stress in a tensile uniaxial tension test. So our shear stress should be less than sigma yield divided by 2. Now the value which we have calculated on the left side is 76.32 megapascal, and we do not know sigma y for A36 steel. So what we are going to do is that we will go to the end of the book, and in that you have to go to the average mechanical property table. So here you can see A36 has yield strength, tensile yield strength is 250 megapascal. So I will write it as 250 megapascal. So sigma yield is this one. So sigma yield divided by 2 will be equal to 250 divided by 2, which is 125 megapascal. Clear? And you can see this is less than 125 megapascal. As I will write it as 76.32 megapascal is less than 125 megapascal. So based on this result, I will write the conclusion. Based on this result, the steel shall not yield according to maximum shear stress theory, which is also known as Tresca criteria, or we can also call as MSS, maximum shear stress. And this is the answer of our this question. So this was all about this problem 10-75. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.